So I'm Thierry. I work at the Oecd, which is an international organization dealing with a lot of different subjects, and whose goal is to do some policy making and to make people gather in order to discuss about, let's say, global problems. Uh, I belong to the IT department technically. I don't really know my exact title, but for me, my title is knowledge gardener. So I take care of your data, and above all, I try to take the best from your data. So in this context, I will speak about taxonomies, the use of taxonomies at the OECD. We've been using MarkLogic for several years now. We've got lots of systems, lots of applications in MarkLogic, not all, but I'm dealing with many of them. And we use MarkLogic because it allows us to do some semantics, to do some reasoning, and to use XML. We are combining everything, and this is one of the platform which is the best place for that. So I'm gonna explain you what kind of taxonomies we use, because the taxonomy is not a frozen object. It can be used in different ways. Very often people are talking about taxonomies, but they don't really talk about the same thing, although they use the same word. You will see that some of our taxonomies are more ontologies than simple taxonomies. So basically, taxonomy is not a product; it's more an art. It's the art of ordinancing knowledge, putting order in your knowledge. It's something you can do at home, just while writing your shopping list or things like that. That's something sometimes you do in your head without even talking about taxonomies. Uh, but that's more a way of working than anything else, because the different product that you can call taxonomies may be really different, really heterogeneous. So the first kind of taxonomy you may encounter is really basic. Is really basic. That's something you can even find in SQL or in other systems. These are taxonomies just as reference lists. You want to bring some consistency in your application. You want to to have shared code list, for example. These are already taxonomies. These are list of concepts, maybe very flat, maybe very simple, very small, but this is just a way to harmonize your data, to harmonize your codes, your labels, etc. And you can use a same small taxonomy across different applications. It can only be beneficial. So on your screen, you've got, for example, a screenshot of a small taxonomy that we are using across different applications, different uh, heterogeneous applications, which is a taxonomy of budget ranges in euros. So some of our projects are asking their user to evaluate their projects, their programs, their policy initiatives, or their policy instruments in terms of budget. And instead of asking for an amount, we ask them to select one of these taxonomic elements. So it's just a way to have an agreement on the different in the different platform using this taxonomy, so that they always use the same URI. And when we have to change, for example, or to add a new taxonomic concept, the replication is automatic on every platform. This is really important. The fact that even for such simplest thing, I say simplest because usually speaking, the way you will see in action this taxonomy is basically in a drop-down box, for example. But even for that, it's very interesting. It's very valuable to use COS format to build you a true taxonomy, because you will be able then to, for example, to add new languages. If you are only in French, you will be able to add very easily an English layer, and it will be let's say, natural, because the SCOS specification allows, and the RDF specification allows you to language qualify your labels. So even for such very simple things, it's beneficial to use taxonomy. Then you've got another kind of taxonomy, which maybe now we are switching from something very basic to something which is much more complicated. At the OECD, we use our main taxonomies, which are topics and geographical areas. Topics are basically either theoretical ideas or concrete objects, like, I don't know, chair or cat, but also economic policy, public investment. And we've got, I don't remember, maybe 7,000 of concepts in French and in English. And geographical areas are basically concepts about everything in the world which has some square meters. It may be an ocean, it may be a town, it may be a country, a simple place without any political signification, but everything which is in the world. And basically, we use these two taxonomies to help us tag our resources. We've got lots of text, lots of documents, a lot of fragments, articles, chapters, etc. And in the context of our semantic applications, semantic search application, we tag everything, every single text, using semantic analysis tools, which is another world. These semantic analysis tools are basically programs, robots, which are able, quote, able to read text, maybe to understand them at the grammatical or syntactic level, and then which are able to detect some key concepts, some key words, key sentences, or key groups of words based on certain patterns or on certain taxonomies. So we've got some main robots which are fed with these taxonomies, and based on these taxonomies, they are able to read the text and to extract words matching our taxonomic concepts. So this is really key for us. These kind of two taxonomies are key for us. But if you use a taxonomy for this purpose, then you cannot just say, okay, for each taxonomic concept, I will have a preferred label in French and a preferred label in English, and then some synonyms. It's not enough, because a machine is going to use them to try and read a text. And you know, in a text, within a text, there's a lot of ambiguity. If I say, for example, if I found the word party in a text, you cannot know which is exactly the meaning of party. So there's lots of ambiguity. When we deal with semantic analysis, we spend 95% of our time trying to disambiguate, to help the machine not to confuse, for example, the Queen Elizabeth II and the ship Queen Elizabeth II, because the machine is really agnostic. It means concretely that when we build our taxonomy, and you can see our taxonomy management tools, which is Enterprise Vocabulary Network from Top Quadrant, we are, of course, creating the usual stuff for taxonomy, indicating the type of concept and this kind of basic stuff, but we are emphasizing labels. We are working a lot on the labels, on the preferred labels, but also on the alternate labels, which may be acronyms, synonyms, and also the hidden labels, which may be, you know, very, how to say that, small deviation from the other labels in terms of hyphens, in terms of singular or plural, when it's not very obvious for the machine. And we also created some custom fields in these two taxonomies in order to manage the ambiguity, in order to explain the machine how to select, when and how to select one or another taxonomic concept. In the term of, in in the example of parties, for example, our taxonomic concept is about parties, I would say that parties like in a trial. It's not about sexualities, because in French, party may have a sexual implication. So we are able to say, for example, if in the same sentence you find the word party, but you find also the adjective sexual, it means that it's not the right meaning. So you don't select the topic. On the other sense, if in one sentence you find the adjective adverse or contractant with the label parties, then you select it because it's in the right context of our taxonomic concept. And we can also insert some blacklist saying if you encounter parties, but with this word before, the working parties, etc., it's not at all our context. We've got that because at the OECD, we've got lots of meetings, lots of working parties. So working parties is something which is written a lot in our reports, and we don't want the machine to mix this meaning of parties and working parties. At the beginning of our work, we didn't have that, and it was a complete mess. And the quality of our tagging was very bad. So we worked a lot, we analyzed the result, we analyzed the documents, and we formalized all this disambiguation in the taxonomy. So this kind of taxonomies, there's a lot of work on the labeling and on the disambiguation fields, but there are also taxonomies with a lot of links, lots of relationships. There's a reason, because when you tag a text, if your text is 40 pages long, for example, you will get a lot of tags. How to know what are the best tags? That's another question. And the taxonomies are also helping us in resolving this problem. You could say, of course, I'm going to say if a tag is found, for example, 100 times, then it's a proof that it's very important. Yes and no. It depends also. For example, the word report at the OECD is really frequent in the documents because we do a lot of reports. So if we just based our ranking on the frequency of the tags, we in each single publication, articles, etc., the tag report will be the most used tags. So we have to create ponderation index based on the standard vocabulary, the most common vocabulary found at the OECD, and we associate to each taxonomic concept, let's say a ponderation number. And then we also take into account the fact that one taxonomic concept has got broader, narrower, or related in order to refine this ponderation index. So the relationships in this kind of taxonomies are also keys to get a good result in tagging. So this is quite complex. This is something that we discovered little by little, because at the beginning we were just using taxonomies, like reference taxonomies, but then working with semantic analysis tools, backed on these taxonomies, we had to extend our model of taxonomic concept to work more on the labels and to work more on the disambiguation process. Of course, it does not mean that these two taxonomies are used only for semantic analysis tools. On the contrary, there is not white or black. This is one of the purposes of these taxonomies. If I go back to this one, the first one, this one is not used at all by semantic analysis tools. We don't have to work on labels, to work on disambiguity mechanisms. But for these ones, yes, we have to. And the role of these taxonomies as a source for the semantic analysis tools is something invisible for the user. it's not in the interface, it's in batch, it's in the background. You do that at night, you tag, etc. But the quality of tagging is really key, and it's backed on this taxonomy and the work we do on these taxonomies. That's also why our taxonomy management tools is not inside MarkLogic, is not connected directly and in real time with MarkLogic. Because if it was the case, and if we were to change something in these labels or in the disambiguation mechanisms, and if it were to be replicated in real time in MarkLogic, certainly sometimes there would be catastrophes, because we have to test. The key things when you work with semantic analysis tools is to do what we call validation, to validate the result of your semantic analysis tools each time you modify the taxonomy. That's why we never replicate in real time our taxonomies. It's too dangerous for us. And even if you change a link, it may have an impact, for example, in some applications in MarkLogic using these links. So it's always separated. And I think that's a good practice. Once we are sure that the taxonomy is correct, and basically we do that every month, we then replicate the taxonomy. And by the way, as it was said previously, we have to make this taxonomy live. There's a life cycle. Every month we produce a new version of our taxonomies, a new version of our semantic analysis tools using the feedback from users or the feedback got from the logs, from the semantic search, etc. And we try to improve, to add new concept, to improve the disambiguation, etc. So that's really key. Otherwise, that taxonomy won't be very useful for a long time. Within 2 or 3 years, there will be some discrepancies with the reality of your work or with the reality of the world. So that was the second type of taxonomies, the one used by semantic analysis. And the third type is kind of the most evaluated. It's really taxonomies in action for the user. So taxonomies as a way to discover information, to help people to find new information they were not even thinking about. So for example, in this kind of taxonomies, we make an extensive use of relationships. So either vertical ones like broader and narrower, or horizontal ones related, or many other, because for example, for the geographical area taxonomy, we don't use cost broader and cost narrower or cost related, because these relationships are not semantic enough. For example, we don't say that France is within Western Europe, is a narrower of Western Europe. We say France is fully located within Western Europe. We don't say that Paris is a narrower of France. We say two things. We say Paris is fully located within France, and Paris has an administrative parent, which is France, because we needed to manage both the geophysical aspect in this taxonomy and the geopolitical aspect also. That's why we created specific relationships, more semantic for us, and that's why our taxonomy are now heading more to ontologies than anything else. Using all these relationships allows us, for example, during a semantic search, to when somebody, for example, is let me show you that. When somebody is looking for vegetable oils in Italy, your result will include also vegetable oil, for example, in Puglia or in Abruzzo or in Rome. So semantic expansion means that the machine is able from one concept to give all the children concept and the grandchildren concept, for example. That's very important because sometimes you type a search query which may be a bit fuzzy, And probably there will be 100 results under vegetable oil in Italy, but there will be also 500 results under vegetable oil in Puglia, because there are more olive tree in Puglia than in northern Italy, for example. So it's a way to help the user. If, for example, you are a newbie in cheese, in French cheese, and your boss is asking you to work on cheese or on dairy products, and you don't even know that the dairy products may be milk or cream or butter, the machine will tell you that. You will discover also things through this semantic expansion. And we use the links in the taxonomy or the relationships to do that. And you may also drift your search and discover new things. In this example, for example, matching the query vegetable oil in Italy, when you open the discovery pane, you are also provided with margarine in Italy or essential oils in Italy, because these are vegetable oils also. They are other kind. They are close concept. But it can apply also to geography. For example, the system knows that Italy has got several neighbors. So then here you are provided with the different neighbors of Italy and the same query, vegetable oils in France or in Switzerland, maybe also in Greece, or things like that. So you could, as far as you've got the knowledge in your taxonomy, you could propose whatever discovery you want. If, for example, you provide me with the side of the road on which each country is driving, I can do some discovery based on this kind of relationships. It has no interest, I agree, but it could be done. I don't know, for an application specialized on transportation or things like that, maybe it could be of interest. So if you've got a need, you can encode the solution in the taxonomy in order to action it in your interfaces. And I would say that if you've got no need in terms of taxonomy, in terms of discovery, it's no use, enhancing a taxonomy or creating relationships. You must have also a goal. A taxonomy without any goal, it's a dead taxonomy. So all our relationships, for example, in any kind of taxonomy, are based on business needs, basically. And the third thing, very important, I talked about relationships inside taxonomies, but one thing really important that we call taxonomic alignment is relationships between different taxonomies. So how to align different taxonomies. So it could be for reference purposes, like aligning the OECD taxonomy with the UNESCO taxonomy and with the IMF taxonomy. Okay, but what is the purpose? But what is more interesting is to create relationships, complex relationships, so that on the screen, you may aggregate very heterogeneous resources. If you consider this example, coming from a real interface, it's on the same page. I just cut some other dashboards. Here you've got two dashboards aggregating different resources coming from surveys. So basically, these are policy initiatives provided by different jurisdictions. So policy initiative talking about innovation. So it's very strange word. And here you've got associated publications to these policy initiatives. These are resources which are tagged with innovation themes, with target groups. There's no notion of topics, for example. And these are bibliographical references which are crawled from outside, OECD publication, EU publications or articles. And basically these publications are tagged with our topics taxonomy. So how can we display on the same screen relevant publication to things which have no common tags? We've got topics here. We've got, for example, themes or target group. Target groups are researchers or students or, I don't know, public institutes, things like that. We do that through alignment. We say, for example, in our taxonomy of target group. For the taxonomy concept researcher, it will match the concept in the topics taxonomy of students, researcher, PhD students, postdoctorate students, or whatever. We create alignment. And then at the time of displaying the data, we create Sparkle requests. We do inferences. It means that coming from this target group, for example, we look in the taxonomy. Okay, this is let's say secondary students. Let's see in the taxonomy what are the topics associated. We've got 3 topics associated. Now we are going to search within this collection of resources all the resources which has got one of these 3 taxonomic concepts coming from the alignment of the target group. In this way, we are able to display on a page dedicated to public-private partnership target groups, for example, or no, maybe I don't know, PhD students were able to display relevant publications, and we can do that also combining several criteria, because on this page we may have a page dedicated about students, but also a page dedicated about students in Russian Federation, in which case we do a double alignment. We get all the resources which are aligned with students, but we get also all the resources talking about Russian Federation or one of his children. It may be a problem of students in Moscow. In this case, we will get also the publication. So it's a way for us to taxonomies are a way to aggregate very different kind of resources, and honestly we like to do that. We love to do that because we can see the value added. It's very easy to set up. It's really easy to change, to tweak, to refine when you think there's a problem, and it's very efficient. And the fourth type of taxonomies, which is a bit brand new at the OECD, is taxonomies as master data. You know, in our organization, for example, especially let's say for countries, when we are writing about one country, we don't have the choice in terms of the preferred label. Our legal department is enforcing a list of country names. What kind of label do you use in French and in English when you are in a text, when you are in a table, when you are in a footnote? There are very strict rules, and for the moment our legal department is not really able to enforce this kind of rules, because we should have we've got different types of databases. It's very difficult to harmonize, and there's no specific mechanism to do that. So now we've got taxonomies which are backed on master data management mechanism, in order to enforce our organization-wide definitions or label of way of designing of displaying things. These taxonomies may be existing taxonomies, such as geographical areas also, but also very simple taxonomies for which sometimes there's no label. For example, there's one project at the OECD which is created, and this project has got some jurisdictions, a list of, let's say, 10 jurisdictions, which maybe are not even OECD countries. So their taxonomy is going to have 10 countries. There will be no label in this country because they will have to back on the legal taxonomy of labels. So it will be a very small taxonomy with some types saying, okay, this is my project countries. Okay, but we are in the process of creating inference mechanism so that each time an application needs to get, for example, a country label, even if this application has its own taxonomy, the legal taxonomy will have a prescience. And we will be sure that the correct labeling is used in terms of countries. You know, we live in a kind of diplomatic world, We cannot say Taiwan, for example. We have to say Chinese Taipei, otherwise there will be a great revolution, a huge revolution, etc. So we must be sure that we can enforce this kind of data, of master data. And the way the taxonomies that we are using and the new taxonomies that we are creating, when you associate them with inference mechanism to ensure the preference, the precedence and preference of master data, you are able to enforce the organization-wide rules. It's very difficult to demonstrate because everything is in the process, not in the interface. It's just when an application needs a list of labels of countries, it's just to ensure that the API, which is going to deliver this list of labels, will be enforcing the rules of precedence in the taxonomies, and will give the priority to the legal taxonomy. If it's an official project. We can also, thanks to graphs, thanks to inferences, we can also imagine that one project has got two views. One official views when writing publication, and in these views, the project will be provided with official and legal labels, but he may have also, let's say, unofficial views for which he will be provided with other kind of taxonomic labels. That's also possible, and that's the beauty of RDF and all the graphs. So this is an ongoing project for us. It's kind of very difficult because you have to everything is in the dialogue between the taxonomic system and the external applications, and lots of these applications does not understand URIs, for example, or things like that. So it's kind of difficult, but it was the precedence mechanism was kind of very easy to set up, and it works well. So we hope that it will also ease the life of our legal department, because they've got sometimes problems with member countries which are not happy because they have been mentioned as, I don't know, Chinese Taiwan. Also, you have to say Chinese Taipei, etc. So this is another way also to use taxonomies as master data. And you could tell me, okay, taxonomies as reference list, the first item I demonstrated, and taxonomies as master data, it's a bit the same thing. Yes and no. Master data are reference list, of course, but behind the scenes, there are mechanisms to enforce the fact that they are master data. And what is important in master data is the mechanism, the enforcement mechanism, even more than the taxonomy by itself. So I think I'm at the end of my presentation. One last thing I would say, and I already said that, is every taxonomy may be of one or several types of all these taxonomies that I presented. Of course, it's not white and black. Our topics and geographical area taxonomy are used as reference list, are used by semantic tools, are used by discovery tools, and are also used in the case of geographical areas as master data. So the world is always gray as usual. Voilà, that's it.